until next section in 8.3. But I want to just point this out again and give it sort of an official name. So here's a definition that I will start using soon. And this is the idea of a probability vector. So a probability vector it's a vector whose entries add up to 1. And furthermore, none of the entries should be negative, right? So whose entries are all not negative. And add up to 1. So if you guys remember a long time ago, I told you about row and column vectors. Those were like matrices either with a single row or a single column. They're like 1 by n matrices or n by 1 matrices. Those are vectors. And so a probability vector is a special kind of vector where all the entries add up to 1. And in particular, none of the entries are negative either, because as the name suggests, I want every entry in the vector to represent the probability of something happening. So every entry of the vector represents some probability. So if you just need a quick example, I don't know, here's a vector. 0.3, 0.2, 0.5. There's a probability vector. These numbers are all between 0 and 1, and they add up to 1. Okay. And so just to notice, each row of a k-step transition matrix is a probability vector. So each row is a probability vector in a k-step transition matrix. I sort of already have pointed this out to you multiple times before, that each row adds up to 1. Now we're just stating this in fancier language. Each row of a k-step transition matrix really just is a probability because the entries add up to 1 and they're not negative. Okay. So this idea of vectors and stuff is going to be really important in section 8.3. We're going to use vectors somehow to solve problems and develop our theory of Markov chains further. But I'm not going to talk about that this week anymore. So I just want to introduce this idea, and again, and just mention that it'll be important next week. So anyway, that's pretty much all I want to say today. I think tomorrow I might open up with a couple more examples. So I'll talk a little bit more tomorrow and do some more sort of different style of examples. But otherwise, the rest of time today, you guys are free to work and ask questions. So if you have any questions or anything, stick around and let me know. Otherwise, take the rest of time to start working on activities. Again, 8.1b is due tonight, and 8.2a and b have been posted. So